So the session is about the trigonometric ratios of complementary angles. So what are complementary angles? The sum of the angles is 90 degrees, then we say the two angles are complementary. If the sum of the angles is 180 degrees, we say the two angles are supplementary angles. Is the session for today. Now that we have already discussed about supplementary and complementary angles, so let me just give a brief introduction. If angle X plus angle Y is 90 degrees, then we say this X and Y are said to be the complementary angles. Now, using with the definition of this complementary angles, let's see how the trigonometric ratios of complementary angles are considered and what outcome comes out of the discussion of trigonometric ratios of complementary angles. To start with the right angle triangle, let me consider a right angle triangle. So this is A, B and C, and let me say the length opposite to angle A is A, and this is B, and this is C opposite to this. So ABC are the lengths of the sides of the triangle, right angle triangle ABC. Let me take this to be theta, angle theta. Then if this is theta and this is 90 degrees, we know that sum of all the three angles of a triangle is 180 degrees. Therefore, this being 90 and this being theta, obviously this would be 90 minus theta is what we get for the third angle. Now this is what makes the definition of complementary angles, because when I sum up angle B plus angle C, I get complementary angles. That is, in the triangle ABC, I clearly see that when I sum up angle B plus angle C, I get 90 degrees, and hence this property is nothing but the complementary angle property. And using this complementary angle property of a right angle triangle with angle B plus angle C equal to 90 degrees, we are going to connect the trigonometric ratios with the property of complementary angles. So let's see how it is possible. So I take two sets of trigonometric ratios for each of the angle theta and angle 90 minus theta. Therefore, if I take theta for angle theta, then we have sin theta equals opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is opposite by adjacent of the respective angle theta. So let's initially find for theta all the three possible trigonometric ratios. So in this case, let me start with sin theta, which I clearly understand that from this triangle sin theta is opposite by hypotenuse. Therefore, my opposite side being B, this would be B by hypotenuse, which is A, comes out to be B by A. So my first trigonometric ratio for the angle theta is sin theta equals B over A. Similarly, let's start with the next trigonometric ratio, cos or cosine theta. So here the cos theta is adjacent by hypotenuse, which is nothing but for the angle theta, adjacent is C and hypotenuse is A. So I get this as C over A. Thirdly, to start with tan theta. Tan theta is opposite by adjacent. Therefore, my opposite to angle theta is B and adjacent is C. So I get this as B over C is what I get for this angle theta, that is angle B. Next, let me take the angle C, which is 90 minus theta, as obtained from sum of all three angles of a triangle. So using this angle, let's see what are the trigonometric ratios defined for that particular angle 90 minus theta. So here for 90 minus theta equals angle C, and here this equals angle B. Let's see what are the possible trigonometric ratios. Sine of the angle here is 90 minus theta. So in place of theta, I get 90 minus theta after the sine. So I need to find sine of the angle 90 minus theta, that is angle C. In this case, it is opposite by hypotenuse, but here the opposite side is not the same as this, because opposite to 90 minus theta is C and hypotenuse is A. For opposite of theta is B and opposite of 90 minus theta is C. So opposite side changes with the angle. This angle has its opposite side here. This angle has its opposite side here. Therefore, for 90 minus theta, my opposite side is C. Therefore, I get C over hypotenuse, which is A. Similarly, I have cos 90 minus theta, which is adjacent by hypotenuse. So adjacent to the angle 90 minus theta is B, and hypotenuse is of course not going to change. It is fixed, which is A. So this would be B over A. And finally, my tan 90 minus theta is opposite by adjacent. Therefore, my opposite being C and adjacent being B is C over B, is what I get for two particular angles, theta and 90 minus theta. Now, as I compare these two trigonometric ratios for the angle theta and 90 minus theta, which are the complementary angles, we come with an interesting outcome that if sine theta is B over A, is nothing but same as cos 90 minus theta, which is also B over A. This matches with this. That means this is equal to this. Similarly, C by A matches this, which makes me understand that cos theta is sine 90 minus theta, because the right hand sides are same, being C over A. This being C over A and this being C over A. Thirdly, I have tan theta is B over C, tan 90 minus theta is C over B, which makes me understand that this is reverse of this. That is, each of them are reverses of each other. So that makes us understand that one gets converted into cot, tan to cot or cot to tan. So initially, to start with, let's identify the first two trigonometric ratios with their comparison. So here I identify that sine theta is clearly cos 90 minus theta. That is, we have a formula, this equals this and this equals this. So let's start with sine. So I have sine 90 minus theta is C over A, which is equal to cos theta. So this is the formula which is extracted from the trigonometric ratios of a right angle triangle. And similarly, my cos 90 minus theta is sine theta, is what I get from the ratios. Further, tan 90 minus theta is C over B, which is nothing but 1 by B over C, because C over B I can write as 1 over B over C, so that this reduces to 1 by B over C, which is clearly tan theta, and therefore this one substituted here gives me 1 by tan theta is cot theta. Therefore, I have three derived formulae. Sin 90 minus theta is cos theta, cos 90 minus theta is sin theta, and tan 90 minus theta is cot theta are the three basic formulae which are identified for the trigonometric ratios connected with complementary angles, deriving three basic formulae: sin 90 minus theta equals cos theta, cos 90 minus theta equals sin theta, tan 90 minus theta equals cot theta, is what we conclude.